Hi Junior 5 students. Our lesson for today talk about the light, but let's have a short introduction. In the last year you studied the forms of energy, and now you know that there are many forms of energy. We have a sound energy, heat energy, potential energy, electrical energy, kinetic energy, light energy, nuclear energy, magnetic energy. But in this lesson we will focus on the light energy. First, what is the light? Light, it is the energy which we can see. Look, there are many forms of energy, but you can't see any form of these energies except the light energy. We just can see the light energy. So the light is the energy which we can see. We classify the light sources into two classes. We have a natural light sources like the sun, stars, the moon. These sources are made by the God, but we have a man-made sources or the artificial sources of light like the kerosene lamp, torches, electric lamps, candles. So you can ask yourself now, what are the light sources? Hey, we have two sources of light, natural sources and man-made sources. Give reason. The sun is the main source of light. Yes, the sun is the main source of the natural light. Why? Because it is a star. It emits heat and light. Give reason. The moon is not a real source of light. Yes, the moon is not a source of light, as it is a dark body, as you studied before, as it reflects the sunlight. It reflects the sunlight, fall on it. So we can't consider the moon as a real source of light. Now let's talk about the light properties, and we will study each property of this in details. So the light travels in straight lines. The first one, the light travels in a straight line. Number two, light transmits through different materials, as we have a transparent, semi-transparent and opaque. I will explain that. Number three, light reflection. Reflect. It means that it return back again. Light refract as light can change its direction. Light separation. Okay, let's begin. Light travels in straight lines. We can see the candle's light when the three holes on the same straight line. We can see the candle light when the three holes on a straight line. Let's see an activity that explains that to you.
P34 to show that light travels in straight lines. We will use this apparatus.
Look,
three metal
we have three screens, and each screen contains one hole in its center, and we will use a laser pen to explain that light travels in a straight line. Look, the laser beam travels through the three screens in the same straight line and can pass through. But this when the three screens in the same straight line. But what happens if we move one of these screens? Look, the laser beam passes through one of through the first screen and can't pass through the second screen. So light is travels in a straight line, not in a curved or zigzag. So in this activity proves that light travels in a straight line. Light travels in a straight line. Then light travels in a straight line. Again, the second activity is formation of the shadow. What is the shadow first? Shadow, it's the dark area formed behind the opaque object when the light falls on. When you move in the light, you can see the shadow of you on the wall, as your body is an opaque object as the light can't pass through. So the dark area that you form on the wall is called the shadow. So the shadow is the dark area formed behind the opaque object. When the light falls on, the dark area is the shadow. The dark area is the shadow. And this activity and this shadow proves that light travels in straight line, as if the light not travels in a straight line, it can pass behind you and get this dark area as a light area. So this is a shadow, and this activity proves that light travels in a straight line. Again, light travels in a straight line. This is the third activity that proves that light travels in a straight line. When the light passes through the narrow hole is a small hole. It forms a minimized and inverted images, and this is the idea of the photographic camera. A pinhole camera, and this is the first camera that they invent. Look, this animal or this object here reflects the light, and the light cannot pass in the straight lines parallelly in this narrow hole. So it forms a minimized and inverted image, and this is the idea of the photographic camera. This activity proves that light travels in straight lines. Now we have three activities that can prove that light travels in straight lines. The first one that we see the candle's light with the three holes in the same straight line. Number two, forming the shadow. Number three, the formation of the minimized and inverted images through the narrow holes. Property number three of the light transmission through the different materials. We can classify the materials around us into three items. Number one, transparent materials. Number two, semi-transparent materials. Number three, opaque materials. First, transparent materials. The materials which things can be clearly seen behind, as the light can pass through it completely. The transparent objects like the air, the clear water, glass, plastic, all these objects we can see what behind it clearly. Semi-transparent materials is the materials which things can be less clearly seen behind. We can see behind it, but less clearly, as the light passes through it partially. That means part of light can pass through it. And these materials like the tissue paper and the frosted light bulbs, so we can see this image but less clearly. Number three, the opaque materials It is the material that don't allow light to travel through, and these things cannot pass the light through it. Look, we can see the image behind this opaque object. These objects like the rocks, wood, cartoon books. So light transmission through different materials. These materials are transparent, semi-transparent, and opaque. Property number 3, light reflection. What is the reflection? Reflection is the bouncing. Bouncing means returning back of the light. When the light ray fall on a reflective surface like a mirror, it reflects and returning back to its the first direction. Again, is a definition of the light reflection is it is the bouncing or returning back of the light rays when the light falls on the reflective surface. Here we have a light ray and we have a reflected light ray, and this angle is called the angle of incidence, and this angle is called the angle of reflection. The angle of incidence must equal the angle of reflection. Okay, if the angle of incidence equals 30, the angle of reflection equals 30 degrees. Okay, there are two types of reflection. We have a regular reflection and irregular reflection. Regular reflection happens on the smooth surface like the mirror or the glass. But irregular reflection, it happens on over anything like the foil paper or any object around us. So regular reflection, it is the reflection on a smooth and shiny object. Reflecting a surface where the light rays are reflected in one direction. Look, the incidence rays fall on the reflective surface and it reflected in the same direction. They are parallel. They have the same direction. But in the irregular reflection, and it is the reflection on a rough reflecting surface where the light rays are reflected or scattered in many different directions, like the white paper. So you can see your image on the mirror due to the regular reflection, but you can see your image on the white paper as it's an irregular reflection, as the reflected rays are scattered everywhere. We have a problem if you put an object at a distance of 20 centimeters in front of the mirror. So if you want to calculate the distance that the image of this object behind the mirror, you can calculate it easily, as the distance between the mirror and the image equals 20, and the distance between the object and the image equals the object and the image equals 40 centimeters. But if you want to calculate the distance between the image and the mirror, it equals 20, like the distance between the object and the mirror. So it's easy. Give reason. We can see things around us. Why we can see the objects around us? We can see the object around us due to the reflection. It's short answer. Due to the reflection. Can you explain that? Yes, because they reflect the falling light on them to reach our eyes. So when the light falls on the object, it reflected to our eyes. So you can see this object. So if there's no light, you can't see any object. We can't see in the dark. Al-Hassan ibn Haytham is the first scientist inferred seeing objects. Property number 3, light refraction. What is the refraction? Refraction, changing the direction. As I told you that the light travels in straight lines. Light travels in straight lines, but in one medium, in the air. But, as example, but what happens if the light travels in the air, through the air, and falls through the water? What happens? The light refraction happens. As refraction, it is the change in the direction of light rays when the light passes through a separating surface between two transparent media. Again, what is the light refraction? It is the change in the direction. Change in the direction. Look, light travels in straight line. It changes its direction when it passes the separating surface between those two transparent media. Okay. Here you are some examples. As due to this property, which is light refraction, we can see this pencil broken and this spoon broken when we put it in the glass of water. Give reason. Light refraction. Why the light refraction happens? Or give reason. The spoon seems broken in the glass of water. Why? Because the speed of light in the air faster than in water. Let me explain that. When the light travels through the air, it has a speed, and when it passes through the water, it has a different speed, and it may be lower than the speed of light in the air. So the light speed is different in these two different transparent medium, as the speed of the light in the air is faster than the speed of light in the water. So as the speed of light in the air faster than in water, so the light is refracted or change its direction here. The final part, light separation. Light separation, it is a separation of white light into 7 colors called spectrum colors. Let me explain that. You can see the light, the white light everywhere, but let me tell you that the white light is not white. What? The white is not white. Why? The white light is a mixture of 7 spectrum colors. 7 spectrum colors, yes, the rainbow. Okay, I will tell you. That light, when it travels through the triangular glass prism, it entered as a white light, but it get out as a 7 colors. Why? The white light is a mixture, as I told you, of 7 colors. These colors, each color of these colors has its speed. So it has a refracted angle here. So the red light refracted, and the violet color refracted, but in a different angle, as it has a different speed. So the 7 colors is separated. Every color go and refracted with its specific angle, and this is the cause of the formation of rainbow. Light separation, it is a separation of white light into 7 colors called spectrum colors. When light passing through the triangular glass prism, this is a triangular glass prism, the spectrum colors are red, orange, yellow, green, blue, indigo, violet. Again, red, orange, yellow, green, blue, indigo, violet. When the spectrum colors are remixed again, white light will be formed. Give reason. We see the rainbow in the sky after raining. Why? Look, this is the sun and there is a rainfall. So when it's raining, the sun rays is entered the raindrops and separated into 7 colors. When the white light separated, it formed the rainbow. So we see the rainbow because of light separation, as when the sunlight falls on the raindrops, it's separated into 7 colors. That's all about the light, and see you in the next